All right, so today we're going to do the average value of a function on a given interval. There's a formula, we'll pull it out in a second, but globally, when we think about this, it is the area under the curve. You're going to replace that area. That is the answer, but you don't want to have it be odd shaped. You want to replace it with a rectangle. All right? So, and the question is where is the height of the rectangle? So to find the area under the curve for the first one, we know that we have to do the integral, -1 to 1, of the function x squared dx. But what kind of function is x squared? Do you know it's an even function? Maybe not. That's okay. You'll learn it. That's why you come to class. So we can take from 0 to 1 instead of -1 to 1, and we do it of x squared. And again, this is pretty easy for us in calculus at this point. Hopefully we'll all see this as x cubed over 3 from 0 to 1. I'm not going to go through the evaluation. It's 1/3 minus 0 times 2. So the area under that curve is 2/3 of this red shape up here. But we want to replace it with a rectangle. How long is the rectangle? Well, we want it to be too long. So in front here, we're going to multiply by a half all the way through. If I remove the 2/3 here, half of 2/3, we get a F average of 1/3. And what that means is if instead of having the red area of the curve, that green rectangle is too long and it is 1/3 tall. It's kind of like average miles per hour when you drive your car.
Yeah.
Start at 0, go to 60, right? And you average about 40. All right. All of that could be done with this one equation. All right? And it is the same thing. You notice here it's 1 to -1. So 1 minus 1 is half. Here is our area under the curve.
Where's the top of the 5?
Where's the top of the 5? I don't know there, Spencer. We'll figure it out. We'll have to figure it out. Say yay math for me. Yay math?
Yay, Matt.
Yay math. We're going to pause here. You guys can try the next two using the formula. All right, so let's use the equation real fast in the first one before we do the other parabola. We'll move this problem down. All right, so again, we don't even need the graph to apply the formula. F average equals 1 minus -1, a to b, of -1 to 1 of x squared dx. And again, if you can see this is even here, you can do the double, but we won't do it this time. We'll just apply the equation straight up. And we better get the same answer, right? We'll use that formula for the next one. So that becomes 1/2. The antiderivative of x squared is x cubed over 3. All right? And then we go -1 to 1. Do a little bit of math here. We go half. We get 1/3 minus a -1/3 when we evaluate 1 and -1. This is negative is a positive, so 1/3, 1/3, 2/3, half of 2/3 is 1/3. Now at this point, someone in the crowd's going, "Man, I'm just going to memorize the formula," right? And it does work, but you want to if you just memorize everything, it gets pretty hard, especially when you have to think average value versus average rate of change. Average rate of change is secant line, 2 points. Average value is making the rectangle. It's understanding area under the curve, all right? So let's erase all this, and let's try the other one up here, and then we'll get to that.
Take a long
These videos do take a long time, Spencer, I agree. That's all right. People like them, I hope. All right, on this one, I am not going to overthink this. Everybody, this is some sort of parabola, do we agree? And it's not symmetrical, it's even and odd.
Yep.
All right. So I would probably use the formula here, thinking to myself, well, it's that interval, right? That's the length of the rectangle. I need to know the area under the curve. So I would just hold the half out. You guys agree it's x squared over 2 minus x cubed over 3. And everybody, again, add 1, divide by the new one, right? Add 1, divide by the new one. That's what's happening here. really doing the antiderivative without thought at this point. All right. Lost the page. All right, so there it is. And I can plug in those values then. I move this down, I get half. 2 squared over 2 minus 2 cubed over 3. And again, be careful here, 0 minus 0. Make sure you recognize that they're actually zeros. I show it.
0 minus 0 is 0.
I agree, 0 minus 0 is 0 over here. And I get 2 minus 8 thirds. So I get a negative 2 thirds inside. All right. So 2 minus, so I get negative 2 thirds inside times a half. And what's the area under this curve? Minus 1 third. Is that possible?
Yes.
It is, because we have to picture this parabola, and I'll draw a quick sketch of it. It is a minus third, all right? Because if I was to do this problem, and I make this all, and I don't know exactly, I got a pretty good idea. You guys agree to go through 0, 0 visually? Go through 1, 1? What it's saying is the area under this curve, the green area, we know it's positive, negative, can be represented with this one rectangle that's negative below. All right? So, last one today. We'll bring this down. And I'm not even sure I'm going to graph this, all right? We'll pause the video, give you a second to work on it. All right, so the trig problem looks ugly. And I agree, it kind of feels ugly. We're going to find the average of this value. And don't get thrown. It is pi over 4 minus 0 in front for the b minus a, right? And it is an integral from 0 to pi over 4 of secant, tangent, d theta. All right? Now, hopefully you've memorized this so it feels almost automatic. The antiderivative of secant tangent has to be just secant. This is one reason in my class we memorize it so hard. And hopefully we do enough math that we can see that this is 1 over pi over 4 or 4 over pi times, and I'm going to do the integral at the same time. And I would say this is the antiderivative of that secant from 0 to pi over 4. I don't think in terms of secant. Not many people do. So I see this as 1 over cosine theta, 0 to pi over 4. All right, pi over, so it's 4 over pi, 1 over cosine of pi over 4, minus 1 over cosine of 0. Fortunately, cosine of 0 we know is 1, so it's minus 1. I don't think of pi over 4 very easily, so I think of the 45, 1 square root of 2. So I think of this as 1 over the square root of 2, 4 over pi. So this is kind of an ugly answer. We're going to be done just by flipping it up. This flips up to just square root of 2 minus 1 inside. And I wouldn't even distribute. That's our F average. And it doesn't mean much to me in this sense. 1.4 minus 1 is 0.4. This is like 1.3. About 1.3 times 0.4. You know, it's about a half. All right? But again, this is the case, especially the last one, where knowing our trig formula and doing this is probably faster than trying to graph out the area of the curve, all right? So, again, AP test is coming. Keep practicing.